Hi, Onelia, how are you?
I'm good. How are you, sir?
Uh, I'm good. I'm good. Thanks for joining the lesson. Then, are you ready for me to start now?
Yes, sir.
Oh, okay. Then let me quickly share my screen now and be busy with whatever is the business for today. Okay. Let me do this. Mm, share the screen. Is there anything that you are seeing that side?
Yes, sir.
Okay. Thank you. Who else joined the lesson? Serena's iPad. Hi, Serena's iPad. How's it? Is it Serena? I don't know if I pronounced that
Good, and you,
name
sir?
correctly. I'm good, thanks. Thanks for joining the lesson. Let me quickly go to the business of today. So, guys, I think I now already taught you everything in Euclidean geometry. So, this week and next week, we will be just doing some question papers to just ensure that you guys are comfortable with everything. Does everybody hear me that side?
Yes, sir.
Okay, then thank you. Is the zooming also okay? Or I need to zoom in or zoom out a little bit?
It's okay, sir.
Oh, okay, thank you. So we are going to do this question now from free state question paper, whereby it is saying in the diagram PAL is a tangent to the circle at the point A. C and B are points on the circle such that CB is parallel to PAL, AB, AC, PB are drawn. PB intersect AC at D, and we are given that angle A1 is 78 degrees. So as usual, guys, I will always recommend this technique, DRCPT, Dr. Cape Town, for you to approach these riders in a correct way. So is there a diameter, guys, in this diagram that we are having on the screen now? Are my friends still there? Or they are out? Can you all guys hear me?
Yes, sir.
Yes, sir.
Okay, okay, thank you. I just wanted to ensure because I didn't hear any feedback. So, is there any diameter, guys, in this circle that you are having now? Oh, it seems like my friends are not confident. But guys, there is no diameter in this diagram. There is no radius that we are having. There is no cyclic quad that we are given. Yes, we are given this information here on the statement that CB is parallel to PAL. Therefore, we are going to use this P here for parallel lines. So we know for parallel lines, we are going to use the technique math is fun. If this line is parallel to that one, we are going to say this angle is equal to that angle, reason being corresponding angles, and you state your parallel lines. If this line is parallel to that line, this angle and that angle are supplemented, they add up 180 degrees. And then if they form something like a Z or N, this angle is equal to that angle, only if these lines are parallel. So we were given that this one and this one are parallel. Therefore, this angle will be equal to that angle. They form that Z shape, this one. Okay, then we also have something here. This one and this one, they form this Z here. Okay, we are done with parallel lines. Then we are having that tangent there. This is the tangent. This is our triangle. Therefore, this angle will be equal to that angle, tan chord theorem. And this angle will be equal to that angle, tan chord theorem. Then now you are done with the analysis. We're just going to dive into the problems and see what you are required to find. Now the question, we are required to determine the size of each of the following angles with reasons. 9.1.1, you are required to calculate the size of angle C. Angle C is this one right here. Okay, and we already did our analysis. So we said this is our Z shape. Therefore, this angle here will be 78 degrees, reason being alternate angles. Then you state your parallel lines. I want to write that degrees here. Sorry, guys. 78 degrees. Then your reasoning alternate angles. Then you state your parallel lines that PAL is parallel to CB. Does it make sense, guys?
Yes, sir.
Okay, thank you. Then, but why am I hearing some feedback from one person though? Does it make sense to everyone, guys?
Yes, sir.
Okay, then let's go to the next question. The next question, ABC. We are required to calculate the size of angle ABC. ABC is this one here, this one there. So that angle, we can see, oh, we have some tan chord theorem there. Remember how we identify tan chord? We say if there is that angle between the tangent and the chord, this is the tangent, this is the chord. So there is that angle between the tangent and the chord. In that triangle, this angle will be equal to the angle in the triangle that is opposite the chord of focus that you're talking about. Therefore, this angle will be equal to that angle. Now, when we go to the problem that we are having there on the screen, okay, this is our triangle. This is tangent. We have the angle between the tangent and the chord. Therefore, that angle will be equal to the angle in the triangle that is opposite the chord. Therefore, this is the angle that you are required to find, ABC. Therefore, this angle will also be equal to 78 degrees, tan chord theorem. Does it make sense, guys?
Yes, sir.
Okay, thank you. 9.1.3, we are now required to find the size of angle A3. Let me just remove this mess right here. Okay, we found this. We found that. Now we want that. Okay, and we can see that now this angle is between the tangent and that chord AB. Okay, and you have that triangle ABC. If this is the angle between the tangent and the chord, it will be equal to the angle opposite to that chord in the triangular circle. Therefore, we already have angle C there. That will be equal to angle A3. This angle as well will be equal to 78 degrees, reason being tan chord theorem, but on that other side. Now let's go to the next question, 9.1.4. We are now required to find the size of angle A2. So A2 is just this one here. So if you have this and you have this, we just found that, and then now you want this, those are the angles on a straight line. You're just going to take 180 degrees minus this angle minus this other angle. Your reason being angles on a straight line. Does this make sense to everyone?
Yes, sir.
Okay, thank you guys. Then we can move to the next problem. We are having this one right here, Gauteng province. Question 8, saying, in the diagram below, tab of TAP is a tangent to the circle ABCDE at point A. So that tangent meets the circle at point A, and then AE is parallel to BC, such that we are also given this information. Okay, DC is equal to DE. Oh, when you look at that triangle DCE, you can see that that triangle is an isosceles triangle. Therefore, it implies that, remember, isosceles triangle is that triangle with two equal sides. If this side is equal to that, automatically this angle will be equal to that angle, reason being angles opposite equal sides. Okay, so in this triangle, if we are given that those sides are equal, this is an isosceles triangle. Therefore, we can conclude by saying this angle is equal to that angle, our reason being angles opposite equal sides. Okay, we noted that. And then we are given TAE as 40 degrees. TAE as 40 degrees, we are given it, here it is. Okay, and then AEB is 60 degrees. Okay, now let's go for the very powerful technique, the RCPT. So when we look at the diagram, guys, there is no diameter. So, okay, we're just going to skip that D. There is no radius. We're going to skip that R. Then the cyclic quad, remember a cyclic quad, I said to you, is a quadrilateral of which the all corners of that quadrilateral are on the circumference. Therefore, okay, this will be a cyclic quad because the point D, C, B, E are all on the circumference. This is also the cyclic quad, okay, because C, B, A, E are all points on the circumference. Therefore, those are cyclic quads. Okay, and then what do we know about the cyclic quad? Is that this plus this 180 degrees. Reason being, opposite angles of a cyclic quad are supplementary. We also have this angle and that angle are supplementary on that red cyclic quad. Now, when we go to the blue cyclic quad, okay, you can say this angle and that angle are supplementary, and this angle and that one are supplementary. Okay, we are done identifying cyclic quad. Let's go to P, parallel lines. Oh, we were given this information here. So we're gonna use it with our Maths fun technique. Okay, these are our parallel lines. Therefore, this angle will be equal to that angle. Okay, because they form alternate angles. Then you state your parallel lines. And what else? For cointerior angles, we can say this angle and that angle are supplementary. This and that are supplementary. Okay, then we are done with parallel lines. Let me just go take it, go for the tangent. Now, yes, there exists a tangent here. And then there's some triangle here. Therefore, this angle will be equal to that angle, reason being tan chord theorem. And this angle here will be equal to that angle, reason being a tan chord theorem. Now we are done with our analysis. Let's just quickly dive into the problems and see what we can do there. So 8.1 is saying identify two cyclic quadrilateral, of which, oh, we already did. So we said the cyclic quad, first one is this one, BCDE is the first cyclic quadrilateral, BCDE. And then the second one we said is this one, this one. Therefore, we can just write it, it's A, B, C, E. Then you're done. Are you guys still following that site?
Yes, sir.
Okay. Are you still all right? Oh, I lost someone somewhere. Are you guys still fine?
Yes, sir.
Yes, sir.
Okay, thank you guys. 8.2 is requiring us to determine with reasons the size of the following angles. We are required to find the size of angle B2. Oh, we already did that. B2 is this one right here. So B2 is just going to give us, oh, where's my eraser? This one is just going to give us 40 degrees. Reason being tan chord theorem because of this triangle and the chord. That is the angle between the tangent and the chord. Therefore, it will be equal to the angle in the triangle that is opposite the chord. Okay. And then the next one, number 8.2.2, is requiring us to calculate the size of angle B1 now. B1, we can see that, okay, these are parallel lines. and then this angle and that angle, they form this Z shape. Therefore, angle B1 will be equal to 60 degrees, reason being alternate angles. Then after saying that alternate angles, please guys don't forget to write those parallel lines. You are going to write it like this. You can just say alternate angles are equal. Then after writing this, specify your parallel lines. AE is parallel to BC. Then you are done just like that. Okay, let's go to the next question. Is requiring us to calculate the size of angle D. So, okay, we said this is 40, and then we found this as well here. We said it's 60. And we said this is a cyclic quad. We said this is a cyclic quad. Therefore, opposite angle of a cyclic quad are supplementary. So if we take this angle B1 and angle D there, we are going to get 180 degrees. Therefore, angle D there will be equal to 180 degrees minus angle B1 minus 60 here. Reason being opposite angles of a cyclic quad are supplementary. Therefore, it will give us 120, if I'm not mistaken. But you guys can correct me if maybe I made some mistake there. So the last one, 8.2.4, we are required to calculate the size of angle E1. So where is E1 is there? Okay, so we now have angle D here. And then when I was starting with this question, when we were given this information that DC is equal to DE, we said we can see that this is a isosceles triangle. Therefore, we can conclude by saying this angle is equal to that angle, reason being angles opposite equal sides. Therefore, what we can do, we can just let that angle be X. Let this angle be X. Therefore, this will also be X, reason being angles opposite equal sides. Therefore, now we want the size of that X there. We can just say, okay, the first X plus the second X plus 120. They will give us 180 degrees, reason being interior angles of a triangle are supplementary. So we are going to have 2x is equal to 180 minus 120 will give us 60. Okay, it's divided by 2. Therefore, x will be equal to 30 degrees. Therefore, now you can see that this angle is 30. We have 30 here, we have 30 here. So this is 30 degrees. Then you're done just like that. Does it make sense to everyone, guys?
Yes, sir.
Okay, I hear feedback from one person. How many persons are even here in the room? Let me just confirm. Oh, we have two people. We have two people. Does it make sense to the other one? Because I only heard some feedback from one person here. Oh, she's still quiet. Oh, she left. Why is she leaving us, Oneide?
I don't know, sir.
Oh, hey, maybe she's not comfortable. Okay, let's just continue with the lesson. So please just shout out Oneile if you don't understand or if maybe I move too fast. Just shout out, okay?
Yes, sir.
Okay, thank you. Then let's go to the other question. This question here. Okay, it's a nice question. So I will ask to just ask you some question with this one on what do you think we can do to approach this question. But let's first do some analysis. Okay, let me just do this a bit. Okay, question 8, you're saying in the figure below, A, B, C, D is a cyclic quad. Okay, you already have something once they tell you that something, the cyclic quad, you know the properties of a cyclic quad, that opposite angles of a cyclic quad are supplementary. Okay, therefore, if opposite angles of a cyclic quad are supplementary, this angle and that angle will give us 180 degrees. Also, this angle and that angle will give us 180 degrees. Okay, let's continue with our statement. They are saying, okay, in the circle center. Now there is a center. Therefore, those lines that moves from the center to the any point on the circumference will be the radiuses. Okay, now there exists a radius in this diagram. And triangle DOB is drawn. DOB, okay? Then DS is a tangent. DS is a tangent to the circle at D. Okay, they meet there at D. Also given that BC is equal to DC, and the angle CDS is equal to 40 degrees. So what are we going to do here? Okay, let's go for the technique. DRCPT. DRCPT. So diameter, oh no, there is no diameter. R, yes, there is the radius. This is the radius. This is the radius. Therefore, triangle BOD is an isosceles triangle. Therefore, this angle here will be equal to that angle there. Reason being, angles opposite equal sides. Okay, and then since there is a radius and a tangent, there is that theorem that is saying a radius is perpendicular to the tangent. If this is the radius, therefore there will be that 90 degrees at the intersection. Okay, therefore this will be 90 degrees here, this angle here. Okay, and then what else? We are done with the radius and the cyclic quad, or we noted that already, that this and this are supplementary. This and this are supplementary. We are done with this. P, there are no parallel lines. Okay. T, there is a tangent. Therefore, we can look for something like a tan chord. This angle will be equal to that angle. Okay. Then we are done with our analysis. We can just jump into the problems there and see what we can do. So, is my friend still there? Oneile still there? So, Oneile, are you there? I'm going to ask you some question on how do you think? How do you think we can calculate 8.1.1, the size of angle BDC?
So since we can use the cyclic quad theorem.
Okay, so you are saying we are going to focus on this cyclic quad.
Yes, sir.
Okay, and then what are we going to do now next?
And we also going to look at we can also look at the tangent.
Okay.
And try to find
I
D3.
love it here. Okay, this is the tangent. And try to find what?
D2, 3, and 4.
D2, 3, and 4. You mean this angle?
Yes, sir.
Okay, now how do you think we can find that? Because the question is requiring us to find this angle BDC, which is D2 in this diagram. We're required to find this angle D2 here, BDC. In the triangle BDC, yes, we are required to find angle D2. So using our analysis that we just made, so we said, okay, this is the tangent. and then this is the triangle. Okay. Do you agree when I say, oh, let me erase this. This is the triangle there. That triangle I'm going to focus on. Now, do you agree if I say this angle here, angle B1, is equal to 40 degrees?
Yes, sir.
What is the reason behind that statement?
Angles of I'm not sure, but like
Oh, okay. You wanna give it a try?
Hancock theorem.
Oh, yes, 100% correct.
Yes.
100% correct. Because this is the triangle, this is the tangent. We have that angle between the tangent and the chord. And then now we want that angle in the triangle that is opposite the chord. Yes, that angle is 40 degrees. I agree. Now I'm asking you again, do you agree when I say to you now this angle here? Okay, we said this is 40 and we agreed on that. Do you agree when I say this angle D2 here is 40 degrees?
Yes, sir.
What is the reason behind that?
Opposite angles of an isosceles triangle are equal.
Sorry?
So the opposite angles of the isosceles triangle are equal.
Oh, oh, it's a good try, but opposite angles. Not really. Okay, if you want to use the opposite angles, opposite things, reason, you should just say angles opposite equal side. Then if you want to use the isosceles triangle, you just say the base of an isosceles triangle. I don't know if this makes sense.
Yes, sir.
Are you sure?
Yes, sir.
Because if this is an isosceles triangle, these sides are equal. This is an angle, this is an angle. This angle is opposite that side, this angle is opposite that side. Therefore, these are the angles opposite those equal sides. Or you can just say the base of an isosceles triangle. The base of an isosceles triangle is this one. This is the base. Therefore, they focus on these angles. Does it make sense?
Yes, sir.
Okay, thank you. Now we are done with this question. Let's go to the next one. We are required to calculate the size of angle C. Angle C is this one. Do you have any idea of how we can calculate the size of angle C?
No, sir.
Oh, okay, no, it's fine. Now let's come to this triangle. This triangle. We already have this angle. We already have this angle. We want the third angle of a triangle. Therefore, you can just say now angle C is equal to 180 degrees minus that angle 40 degrees for this part, and then minus the other 40 for that part. Therefore, that will give us 100 degrees for angle C. The reason being interior angles of a triangle are supplementary. Do you agree?
Yes, sir.
Okay, thank you. Then we are done with this one. Let's go to the other one, 813. We are now required to find the size of angle A. Okay, we have this angle, we have that angle, we have this angle. Now we want this one. Do you have any idea of how we can calculate this one now? Angle A.
So since angle C is
It's 100, yes.
100,
Yes,
we can
okay, that's
say
100. We can say what?
We can say angle O1 is double the...
Oh, we want angle A now, right?
Oh, yes, sir.
Yes. So you are saying angle O1 is what?
Angle O1 will be double the angle of C1, of C.
I disagree. This is the angle that will be double this angle. Then O1 here will be double that one.
Oh,
Do you agree?
yes.
Okay, thank you. Then you can just try another approach, but nice try though.
So, sir, does that mean that angle O1 is half of angle C?
O1 is half of angle C.
Yes, sir.
Oh no. Wait. Let me go back to this and ask you some question. DRCPT. Is there any radius in this diagram? I mean, a
Yes, sir.
diameter. I'm sorry. Okay, you are saying yes, there's a radius. Is there any diameter?
No, sir.
No. Is there a cyclic quad?
Yes, sir.
Where is that cyclic quad?
BCDO.
BCDO.
Yes, sir.
Oh, I disagree. Do you remember what a cyclic quad is? I think I said that on this question. Oh, yes, on that question. I said to you guys, a cyclic quad is a quadrilateral. Let's say this is a circle. If this is a circle, it's a quadrilateral whereby its four corners are all on the circumference. So now if we are saying BCDO, it's a cyclic quad.
Mm.
When you look at that corner now, it's no longer on the circumference. Therefore, BCDO is not a cyclic quad.
Yes, sir.
Do you see that?
Yes, sir.
Okay, thank you. Therefore, now, do you agree if when I say this is a cyclic quad?
Yes, sir.
Yes, this is a cyclic quad. And we have, do you still remember the properties of a cyclic quad?
No, sir.
Okay, the properties of a cyclic quad, the first one, and that we use the most, is that if this is a cyclic quad, then this cyclic quad is A, B, C, D. Now I'm going to say to you, opposite angles of a cyclic quad are supplementary. Therefore, this angle plus that angle will give us 180 degrees. The reason behind that statement will be opposite angles of a cyclic quad are supplementary. Then we come to the other opposite angles. This angle and that angle there are supplementary. When you add those two angles, you will get 180 degrees. The reason being opposite angles of a cyclic quad are supplementary. Does this part make sense?
Yes, sir.
Okay, thank you. Then now when we extend maybe a line here, DC, let's say maybe E, then there's this theorem that is saying this angle here is equal to that angle there. Reason being, exterior angle of a cyclic quad is equal to interior opposite angle. Can you hear that?
Yes, sir.
Okay, thank you. Then we have the last part of the quadrilateral, which is the family of the cyclic quad. I said to you guys, if we have the circle and you have some quadrilateral or a shape that forms a bow tie shape, something like this, we have A, B, C, and D. Now, you can say this angle is equal to that angle. Reason being, angles in the same segment. And then again, you're going to say this angle is equal to that angle. Reason being, angles in the same segment. Does this part make sense?
Yes, sir.
Oh, are you sure?
Yes, sir.
Oh, okay, thank you. Now, let's go back to our question there, where we are required to calculate the size of angle A. Remember, we found this angle as 100 degrees, right?
Yes, sir.
100 degrees. And we said this is a cyclic quad, right?
Yes, sir.
Then now you remember the first property I just told you of a cyclic quad.
Yes, sir. The opposite angles are supplementary.
Yes, opposite angles of a cyclic quad are supplementary. Therefore, this angle and that angle are supplementary. Now you are going to say angle A plus angle C. Those are angles. You will get 180 degrees. Then remember, you will write your reasoning there. Opposite angles of a cyclic quad are supplementary. Okay, the A is the unknown that you're looking for. And then C is 100 degrees is equal to 180 degrees. And then angle A will be equal to, when you transpose that to that side, it's going to be 180 minus 100. Therefore, our A will give us 80 degrees. Then you are done just like that. Does it make sense?
Yes, sir.
Are you sure?
Yes, sir.
Okay, don't be shy to shout it out. If you don't understand, I don't mind to repeat anything. So let's go to the last question of this part, whereby now we are required to find the size of angle O1. I'm giving this to you now. We are required to find the size of this angle. What do you think about this one?
Sir, I think it's going to be.
Sorry?
I think we're going to use how angle DOB is an isosceles.
Okay. Which is the isosceles? Which one is the isosceles triangle?
OD and B.
O OB. Oh, I agree. Yes, that this is an isosceles triangle. Okay, and then now how are we going to use that to find the size of angle O1?
So can we try find uh angle B3 and B2 first?
D3 and B2.
Yes, sir.
Oh, okay. How do you think we can find those?
I don't know.
Oh, okay. Let me just quickly check if it's still only you in the room. Oh, I don't know where are your classmates?
I don't know, sir.
Oh, maybe they're still having some good Sunday. Oh, I don't think there's a way we can find angle D3 and B2 geometrically, but I think you didn't notice this part. This is theorem 2. Did you notice that? This is angle at the
Yes,
center.
sir.
And I said this somewhere, somehow, that this angle is 2 times that angle. And we have that angle as 80 degrees. Therefore, this angle will be 160 degrees. Do you agree?
Yes, sir.
Are you sure?
Yes, sir.
Okay, we are done with this one. Do you have any question with this question that we just did here?
No, sir.
Are you sure?
Yes, sir.
Oh, okay. Then if you are sure, let's proceed to the next part. Oh, I love this question. Well,